Alright, here's example 2 with reference triangles. So this one's going to be just a tiny bit more complicated than example 1. It's a little bit different in the way the question is, or the way the problem is phrased here. So in this example, we're given the value of a trig function, and we're told what quadrant theta is in. Okay, so that's good. Being directly told the quadrant is good because sometimes we might have to do a little work to figure that out, which we'll see in the next couple of examples. But anyway, for example 2, sine of theta is 1/6, and theta is in quadrant 2, and we want to evaluate basically the other 5 trig functions of theta. Okay, so okay, sine of theta is 1/6, and theta is in quadrant 2. So before we continue, we know that theta is in quadrant 2. So let's just so that we'll be safe later on, let's go ahead and jot down somewhere off to the side which ones of these are positive, which ones are negative. Okay, so if we're in quadrant 2, remember that cosine. Okay, so let's maybe come up off here off to the side. So since we're in quadrant 2, cosine of theta is negative, right? Remember, cosine of theta is negative if theta is in quadrant 2. How about the tangent? Tangent of theta is also negative if we're in quadrant 2. Okay, so we talked a lot about the signs, S-I-G-N, signs of trig functions in quadrants. We talked a lot about those in earlier videos. So anyway, what about the secant? Well, the secant of theta is going to be the same as the cosine, okay, as far as this positive and negative go. So if cosine is negative, then secant is also negative. If cosine is positive, secant is also positive. But in this case, cosine is negative, so secant is also negative. Okay. What about the cosecant? Well, the cosecant, remember, that's positive. Okay, cosecant is positive. And lastly, the cotangent is also negative. Okay, so remember, we're in quadrant 2, so really the only positive trig functions in quadrant 2 are sine, which we were given, and cosecant, because it's the reciprocal of sine. Okay, and since sine is positive, the reciprocal is also positive. But anyway, so we just want to jot that down off to the side because that's going to keep things kind of safe for us later. We're not going to be in danger of making a mistake, so just remember that we have this here, and we'll be okay later. Okay, because it could be kind of confusing with the signs, the S-I-G-N signs, whether things are positive or negative. So we don't want to have to worry about that too much. But anyway, so that's first thing we want to do. Okay, well, the very first thing is figure out the quadrant of theta. We were given that, so that's okay. The next thing is, now that we know the quadrant, figure out which of these are positive, which of these are negative. Okay, so we just did that. Now what we want to do after that is draw a picture of what's happening here. Okay, so let's draw a picture of this. So theta's in quadrant 2, so let's have our picture focus on quadrant 2. X-axis, Y-axis. So quadrant 2, remember quadrant 1, 2, 3, 4. Okay, so let's draw our angle theta. So remember theta, we're talking about angles in standard position here. So vertex at the origin, initial side on the positive x-axis, but we don't care about the initial side. We just care about the terminal side. So by the way, when we say theta is in quadrant 2, what that really means is the terminal side of theta is in quadrant 2. Okay, so this is just a short way of saying that. So theta is in quadrant 2 means here's our angle theta, and notice the terminal side is in quadrant 2. Okay, so that's all that means. So here's our angle theta. Okay, now where do we go from here? How do we use the fact that sine of theta is 1/6? So you might be thinking about right triangles, things like that, and that is what we want to think about. Okay, but two things, so we can talk about them in either order. But first, when we're dealing with reference triangles, always drop a perpendicular to the x-axis. Okay, so let me pick some point on here, any point. I'll just pick one over here so I have room to work with. Let me drop a perpendicular to the x-axis. Okay, and then I'm going to fill in this side of the triangle here. So now we have a complete triangle we're looking at. Let's zoom in a little bit also. Okay, so again, for reference triangles, okay, we're talking about using reference triangles to do trig, to evaluate trig functions here. Okay, so for reference triangles, you always go to the x-axis. Okay, never go to the y-axis, never ever go to y, always go to x. Always drop down to the x-axis or go up to the x-axis. Always to the x, never to the y. Okay, so anyway, now what's the other thing that we can talk about here? So let's switch colors. What is this angle in here? What is this angle right here? How does this angle relate to theta? So remember, we talked a lot about it before we started talking about reference triangles. This is an example of, well, this is the reference angle, right? This angle right here, that's the reference angle for theta. Okay, so let's call this alpha. Okay, so we can call it whatever we want, anything besides theta, but let's just call it alpha. Okay, so alpha is the reference angle for theta. Okay, so that's going to be very useful to us. How's that going to be useful? Well, now we can say this. Sine of alpha, let's make that prettier. Sine of alpha equals 1/6. Why? Because alpha is the reference angle. Alpha is the reference angle for theta. And sine of theta equals 1/6. Okay? So remember how reference angles and angles relate to each other? So an angle and its reference angle, they have the same, the trig functions there have the same value. So they have the same sine and all that good stuff, the same cosine and tangent and secant and cosecant and cotangent, except the trig function at the angle may be negative. Okay, it may be negative, it might not be negative. But the trig function at the reference angle is always positive, because remember, reference angles are always acute, and trig functions of acute angles are always positive. Okay, so evaluating a trig function at a reference angle always gives you something positive. Okay, and since the sine of theta is 1/6, that's positive anyway. So the sine of alpha is going to be positive 1/6 also. Okay, so that's what's going on here. All right, now remember, that's just how reference angles and angles relate to each other. We talked a lot more about that in more detail in an earlier video. So anyway, sine of alpha is 1/6. How is that useful to us? Well, now that'll help us set up this triangle. How's that going to help us? So we've done some examples like this before when we talked about right triangle trig. So actually, really, this is just a right triangle trig problem now. But we just have to be careful about what's positive and what's negative. But we don't even have to be that careful because we already labeled it, okay, for our own reference. But anyway, sine of alpha is 1/6. And remember, what is the sine? It's opposites over hypotenuse. Okay? Opposites over hypotenuse. Okay, so sine of alpha is 1/6, which is opposite over hypotenuse. So what we could say then is say, okay, hey, look at this triangle. Sine of alpha is opposites over hypotenuse, 1/6. Okay, so let's call the opposite side 1 and this hypotenuse 6. Okay. Now, technically speaking, there are other ways that we could label this. So we could say 1/6 is the opposite side and 1 is the hypotenuse, but I think that'd be kind of a bad idea. I wouldn't want to do it like that, because then you'll get messy fractions all over the place. Just be very careful with that. But anyway, I think it's easiest to say, okay, 1/6, opposite over hypotenuse, let 1 be the opposite side, 6 be the hypotenuse. Okay, so then that's great, right? That's great. So let's erase this. Let's zoom out a little bit and erase. Okay, so now before we continue, okay, we want to get all these trig functions of theta here. We can only get a few of them right now, but let's, we have to get this length of this side here, right? We have to get the length of this side. Okay, so, okay, x, 1, and 6, how do we get x? Well, this is just a right triangle, right? So we're just going to do the Pythagorean theorem. So x squared plus 1 squared equals 6 squared. Okay, x squared plus 1 equals 36. Subtract 1 from both sides, you get x squared equals 35. Take a square root. X equals, yeah, there's a positive and a negative root, but x represents the length of a side of a triangle. Okay, x represents the length of a side of a triangle, so let's just keep the positive root. So x is positive root 35. Okay. Okay, so x is positive square root of 35 because it's the length of a side of a triangle. Now, now we're pretty much almost there, right? Now we're just going to use reference angles again. So remember how reference angles and angles relate to each other. So if you're not sure about that, you might want to brush up on one of those earlier videos, or using one of those earlier videos. Because from here on out, we're just going to use reference angle stuff. Okay, so it's a little like right triangle trig, just with that tiny little extra bit added with reference angles. Okay, so cosine of theta, remember cosine of theta is the same as cosine of alpha, because alpha is the reference angle for theta, except this might have a minus sign in front of it because cosine of theta might be negative. Well, hey, we found out earlier, or we wrote down earlier that, yeah, cosine of theta is negative because theta is in quadrant 2, okay? So cosine of theta is negative, and because of this right here, okay, theta is in quadrant 2, so because of this, then we have this, and because of this, then we have to put a minus sign out in front, okay? Because cosine of theta has to be negative, so we got to put a minus sign out in front of here, okay? Okay, so we have this minus sign out front here. Well, what is cosine of alpha? Well, we just go to our right triangle and look, okay, cosine of alpha is adjacent over hypotenuse, root 35 over 6, adjacent over hypotenuse. Okay, so this is root 35 over 6. and we do have a minus sign out in front. Okay, again, so the minus sign is here because cosine of theta is negative, so we have to have a minus sign here. That's just how angles and reference angles work that we talked about in an earlier video. And again, the minus sign is here because cosine of theta is negative, and we know cosine of theta is negative because theta is in quadrant 2. Okay, so the rest of these guys work pretty much the same way. Tangent of theta, what's the tangent of theta? It's opposite over adjacent, 1 over root 35. Okay, so, well, actually before that though, remember tangent of theta is the same thing as tangent of alpha, okay? But because alpha is the reference angle for theta, okay? So tangent of theta and tangent of alpha, they're the same, except this one might have a minus sign in front of it, okay? And it actually does have a minus sign because, again, tangent of theta is negative, okay? If we're in quadrant 2, theta is in quadrant 2, so the tangent of theta is negative. So tangent of theta equals negative tangent of alpha, okay? Because we have to ensure that tangent of theta is negative. Okay, so remember, this is just how reference angles work, how they relate to their angles, okay? So negative tangent of alpha, and we just said earlier, tangent of alpha is 1 over root 35, so this is negative 1 over root 35. And if you were one of my students, that's a perfectly acceptable answer, but if you're not allowed to have roots in the denominator for some crazy reason, you could rationalize. Okay. And then you could say, okay, that's just negative root 35 over 35. Which I don't believe is more simplified than just negative 1 over root 35, but oh well, sometimes you gotta do what you gotta do. All right, anyway, secant of theta. Okay, now the secant of theta, remember secant, so we can go back to the triangle here, or we can just forget about that and say, well, hey, I know the cosine, and the secant is just the reciprocal of the cosine, right? So actually now we don't even have to worry about the positive and negative stuff up here anymore. Okay, so we can just look at what we have here, take reciprocals, things like that, so then we're good. Okay, so the secant of theta is the reciprocal of cosine. Cosine is this guy, so take a reciprocal. Secant of theta is negative 6 over root 35. Okay. Or if you have to rationalize the denominator, or if you really insist on doing so, then you can multiply by root 35 over root 35, and you'll get negative, keep the negative there, 6 root 35 over 35. And again, I don't believe that that's more simplified than negative 6 over root 35. Okay, anyway. Okay, so cosecant of theta. Cosecant of theta is just the reciprocal of the sine of theta. Sine of theta we were actually given, so we could have got that one right away. Sine of theta is 1 over 6. The reciprocal is 6 over 1, which is just 6. Okay, that's awesome. And we know cosecant is positive, right? We talked about that earlier, so that just want to show you here that, yeah, that does line up with what we already talked about. Okay, so cosecant is positive. And how about the cotangent? Well, the cotangent, so we can go back to the triangle, but let's not. Cotangent is just the reciprocal of the tangent. We know that the tangent, forget about this rationalizing stuff over here, the tangent is negative 1 over root 35. Okay, we found that out earlier. Negative 1 over root 35. So the cotangent is the reciprocal, which is just negative root 35 over 1, or in other words, negative root 35. Okay? So, or you know, if you really want to do it like this, you'd have negative 35 over root 35, then you'd rationalize the denominator, and you'd end up with the same thing. Okay? So anyway, that's example 2 with reference triangles. So a tiny bit more complicated than example 1. And also, since we were in quadrant 2, we had to worry about what's positive, what's negative. Okay? So that's example 2. A couple more examples coming up next.